Welcome back. In the previous episode, we learned about Ansys Workbench and we got familiar with the tools and the UI of the workbench. We will continue by learning the geometry components in Ansys Fluent. We can drag and drop the Fluid Flow Fluent analysis system to create a standalone system. We can generate a geometry component, or we can generate a mesh component to access the geometry components. When we right-click the geometry components, we see three options: DesignModeler, SpaceClaim, and Discovery. You can think of these as CAD programs provided to you by Ansys. If you have a sophisticated CAD program such as Siemens NX, CATIA, or SolidWorks, you don't necessarily need these. You can generate your entire model through these CAD programs and upload your geometry, update it into the mesh, and carry on. However, there are useful tools provided to you by these CAD programs provided to you within Ansys. The one that we are going to learn about and use is DesignModeler. However, the other two has certain advantages, specifically SpaceClaim. Let's start SpaceClaim to learn about these. As you can see on the bottom left corner, we are seeing that Workbench is indicating to us that it's trying to start SpaceClaim. So, this is the UI of the SpaceClaim, and as you can see, we have certain sketch tools. The important one here, the one that I want to talk about, is this repair tool here. Imagine you are working on a project with a very complex geometry. Maybe you have multiple surfaces, different extrusions, so on and so forth. You upload your geometry into DesignModeler and you get certain errors while trying to generate an enclosure. We will see about enclosure in a bit. You can first of all repair your geometry in SpaceClaim through these curve gaps or merge faces tools. You can, for example, upload your geometry to a single standalone system such as the one here, repair your geometry through SpaceClaim using this standalone component, and then connect this geometry to this one, and then start a DesignModeler or another geometry, and then carry on your work through there. Let's learn about the other one. The Discovery geometry or the Discovery tool is a bit more sophisticated CAD program presented to you with Ansys. As I said, if you're already using another CAD program, which is probably the case, you don't really need this. You can import your geometry through the Import Geometry section here. You need a Parasolid file to import geometries into the Ansys. For example, if you're using SolidWorks, you cannot directly import part files into the Ansys Fluent analysis system or the component system. You need to save that file as a Parasolid file, for example, XT file. Let's start the DesignModeler. After starting the DesignModeler, you can also upload a file through File and Import Geometry file. So this is the DesignModeler. In this set of tutorials, we will focus on two things. One is the external flow, and the second is the internal flow, such as flow through a pipe for an internal flow, or flow around an airfoil for external flow. In order to better understand this, let's first model a geometry inside DesignModeler and see how we can convert that geometry into a system where we can do certain flow analysis on. Modeling parts in DesignModeler is very simple if we are modeling simple geometries. We need to go to the Sketching tab and use the tools that are provided under the Draw tab to model our geometry. Let's model a simple airfoil to study how we can turn that single airfoil into a system where we can do analysis on. Let's draw our airfoil on ZY plane. So imagine we have an airfoil like this. It's not very important for us right now if it's correct or not. We just want to learn the tools of the DesignModeler. So after we have our sketch, we can use this extrude tool here to extrude our solid model. Let's extrude it for 3 meters or 5 meters. After selecting our length, we can click Generate. we have this extruded surface. This blend is basically a fillet tool, and we can generate a fillet here to smooth the edges. So here the fillet is quite small, so let's increase this value to 0.25 and it generates. Now we have this model. So as you can see, this coordinate system is at the left side of our model. We can move this to the center by simply generating another coordinate system. And let's select the XY plane. And for transform, let's select offset about x-axis. And since our model was 5 meters, it should be 2.5 meters. And generate. Now, why did we generate this plane? Because we will use the body transformation, and we will move our body, which is this one, from the source plane of the plane that we generated and to the plane of YZ that we see here. Sorry, to the XY. And when we generate, now the XY plane is at the center of our geometry. This move body transformation and the other body transformations, such as rotate, will be extremely important, specifically when we are learning about Ansys CFX. It is useful to know it now. Under the part and body, we have this surface. The important part here is this fluid solid. This defines our body. For this one, we will keep this as a solid. Now, let's learn about the enclosure. I talked about this in the previous video. I talked about this at the start of this video. The enclosure tool allows us to build a wind tunnel around our object, or mimic a wind tunnel. When we look at the enclosure, we see the name of our enclosure, shape of our enclosure. We can define different enclosures and our lengths. The target bodies also allows us to build a enclosure around a single body if we have, for example, multiple bodied objects that we are trying to run a simulation on. Now let's generate an enclosure. Let's look at this from the isometric view. The x1 determines how long it will be from this x. We are building an enclosure around the selected body, which is this one. The x value defines how long it will be in the x direction. Let's give it 5. The y value defines how long it will be in the upper direction. Let's also give it 5. The plus z value defines in this direction. So let's give it 3. Why? We will see in a minute. Let's also give it 5, 5, and this one, let it be 10. Let's generate. Now this is our box. So we gave in this part a very small length and in this part a large length, and when we look at it from the front, for the up and down and the sides we kept it same. Why did we give short length here and long length here? Actually we can increase the length of the minus set to even 20. The reason why we have this is because we want to investigate. The important part here is understanding what is going on behind this geometry during the simulation. So in order to better model this, we need more length here. We can also increase the length of the front part to better, for example, model the stagnation point if we have a large stagnation point. But the important part here is to, when we are using this enclosure tool, generate more space in the back of our model. Now, we will name these solid bodies. First of all, this is not a solid body. When we generate an enclosure, it's automatically, as you can see here, named as the fluid body. So let's define this as the fluid domain. This represents the air around our solid body. And let's define this as solid domain. We have two different domains. we can reduce it to 1 using the Boolean tool. But let's first talk about what we will do here. Now imagine you put a spoon into a glass of water and you freeze it. And when you remove that spoon, you will see that the shape of the spoon is left inside that frozen water. Because when we remove that spoon, the water which surrounded the spoon will protect its form as it's in the solid form. A similar situation applies here. When we remove this solid body, the surrounding will still hold its shape. Because when we think of it as a frozen system in this first instance, it will protect its form just like that frozen water. And we can remove the solid body from this fluid domain in order to just be left with one single domain. We can do that by Boolean subtraction. We can also unite multiple bodies, for example, these two bodies, to generate one single body. We would do this, for example, if we have a geometry with multiple different bodies, such as a helicopter rotor. Let's imagine we uploaded a helicopter body to the Ansys, and Ansys reads it as 4 different bodies, but we want to use it as a single one so that we can generate another Boolean operation on it to subtract it from the fluid domain. We can use Boolean addition to combine them together. But right now, we want to subtract the solid body from the fluid domain. So we will delete that Boolean operation and generate another one. This time we will select the subtract. So the target body and tool body. You can always delete and go back, but if you don't want to get confused, you can think of it as removing a notebook from your bag. So the target here is the bag, and the thing that we remove is the notebook. So our tool body will be the notebook, in this case the solid domain, and our bag, the target body, will be the fluid domain. And we are left with this. As you can see, the solid body is removed from inside the fluid domain, and we are left with a gap inside our fluid domain. And when we run the simulation, the air will simply move around this. But we don't have to do this. This makes our system simpler, but if you are working on a very complex geometry, you won't be able to always do this, because sometimes Boolean subtract operation won't work on a complex geometry. So you can simply generate this enclosure and carry on. So you can remove this one as well, but 99% of the time, if you have a simple geometry such as this one, generate a Boolean operation and subtract it from the fluid domain and carry on with a single domain. So I said to you, you don't have to use this DesignModeler option. You can just use a more sophisticated CAD program. Well, for example, if you're using SolidWorks, you already have this airfoil. Well, you can generate this box using enclosure and use the cavity option to remove this from inside that solid box and be left with what we just modeled in DesignModeler here. And then in order to avoid any problems, you can upload that geometry, select it as fluid, and carry on with your simulations without having to do any of these. Most of the time, when you're dealing with simulations, you already design some parts, or you already have some parts and you want to do simulations on that part. And there are useful tools that are provided to you in DesignModeler that can help you with that. For example, for internal flow, we have this fill command. Let's imagine that you have a hollow pipe. Let's draw a hollow pipe here. Of any thickness and extrude this. Now you have this hollow pipe and you want to analyze the flow inside this hollow pipe. We have this solid body, but we don't have the internal fluid. Normally you can just draw this internal part of it and carry on your simulations. Just model the internal fluid part. Here I draw a very simple part, but imagine you have a very complex one. Let's say this comes around here, goes up, goes left, goes down, so on and so forth. And you don't want to model that entire complex thing again in the CAD model. You can use this fill tool. After selecting the fill tool, we can select this internal face and apply, and we can select the extraction type and click generate. And as you can see, now we have filled it with water or whatever fluid that we want. Again, we check this fluid solid parts to see what is what. And let's name this as, for example, pipe, and this as liquid. Naming these parts are very important because they will allow you to select in the setup part more easily. We can also generate another Boolean operation here to only be left with this liquid. Now we're only left with the liquid part. And once again, we only have a single domain, which is the fluid domain. This is it for the second episode. In the following episode, we will talk about mesh, and we will learn how to do mesh operations on the external and the internal flows. Thank you for watching.